What if I told you that every single morning when you check your smartphone for directions, you're actually using one of the most revolutionary scientific theories ever conceived? What if the GPS that guides you to work relies on the same principles that govern black holes and the bending of spacetime itself? Welcome to the extraordinary world of Einstein's theory of relativity. Not locked away in dusty physics textbooks, but alive and working all around us, every single day. Most people think of Einstein's relativity as something abstract, something that only matters to scientists studying distant galaxies or particle accelerators. But here's the mind-blowing truth. Einstein's insights are so fundamental to how our universe works that they're embedded in the very fabric of modern life. From the moment you wake up to the time you go to sleep, you're surrounded by technologies and phenomena that would be impossible to understand or even create without Einstein's revolutionary ideas about space, time, and gravity. Consider this. Right now, as you're listening to this, there are satellites orbiting Earth at incredible speeds, about 14,000 kilometers per hour. These satellites experience time differently than we do here on the ground. According to Einstein's special theory of relativity, time actually runs slower for objects moving at high speeds. But here's where it gets even more fascinating. These same satellites are also farther from Earth's gravitational field, and Einstein's general theory of relativity tells us that time runs faster in weaker gravitational fields. The result? Without accounting for these relativistic effects, your GPS would be off by about 10 kilometers every single day. Imagine trying to navigate to a coffee shop and ending up in the next town over. The engineers who designed GPS systems had to program Einstein's equations directly into the satellite's computers, making constant adjustments for these time differences that amount to mere microseconds but accumulate into massive errors if ignored. But GPS is just the beginning of our relativistic journey. Have you ever wondered why gold has that distinctive, beautiful yellow color, while most other metals appear silver? The answer lies deep in Einstein's theories and the behavior of electrons moving at incredible speeds within gold atoms. Or consider the powerful electromagnets in MRI machines that can peer inside your body. These rely on relativistic effects to generate magnetic fields strong enough to align the protons in your tissues. Even the electricity powering your home depends on electromagnetic induction, a phenomenon that's intimately connected to the relativistic relationship between electric and magnetic fields. When you turn on a light switch, you're harnessing principles that Einstein helped us understand in ways that Newton never could have imagined. Perhaps most remarkably, the very atoms that make up your body are held together by forces that can only be fully understood through relativistic physics. The binding energy that keeps atomic nuclei stable, the fusion processes that power the sun and provide the energy for all life on Earth, the radioactive decay that heats our planet's core and drives plate tectonics. All of these fundamental processes follow Einstein's famous equation E equals mc squared, revealing the profound equivalence between matter and energy. Today, we're going to embark on a fascinating journey through your everyday world, but with Einstein as our guide. We'll discover how his theories explain why your smartphone works, why the sun shines, and even why you can see yourself in a mirror. We'll explore how particle accelerators use relativity to probe the deepest secrets of matter, how nuclear power plants convert tiny amounts of matter into enormous amounts of energy, and how doctors use relativistic effects to treat cancer. By the end of our exploration, you'll never look at the world the same way again. You'll realize that Einstein's genius isn't just preserved in museums or textbooks. It's alive and working in the palm of your hand, in the sky above your head, and in every atom of your being. So prepare to be amazed. Because the universe is far more strange, beautiful, and interconnected than you ever imagined. Now that we've glimpsed the hidden Einstein all around us, let's dive deep into the most accessible example of relativity in action, the remarkable device you probably have within arm's reach right now. Pull out your smartphone and open your Maps application. What you're holding isn't just a piece of technology, it's a window into the fundamental nature of space and time itself, a device that literally cannot function without Einstein's most profound insights about the universe. Every time you ask your phone for directions, you're participating in one of the most sophisticated demonstrations of relativistic physics ever created. 24 GPS satellites are orbiting our planet right now, each one a flying laboratory that proves Einstein's theories correct thousands of times per day. But here's what makes this truly extraordinary. These satellites are living in a different time stream than you are. Picture this. Imagine you have an identical twin, and one day they decide to become an astronaut. They blast off into space and begin orbiting Earth at the same speed as GPS satellites, roughly 14,000 kilometers per hour. According to Einstein's special theory of relativity, something remarkable happens. Time itself begins to slow down for your twin. From your perspective on Earth, their clocks tick more slowly, their movements appear sluggish, even their aging process decelerates. This isn't science fiction. It's measurable, predictable, and absolutely real. For GPS satellites, this time dilation effect causes their atomic clocks to lose about 7 microseconds every single day compared to identical clocks on Earth's surface. 7 microseconds might sound insignificant, but remember, these satellites determine your location by measuring how long radio signals take to travel from space to your phone. Light travels at 300 million meters per second, so even a microsecond error translates to a 300-meter mistake in your calculated position. But wait, the story gets even more fascinating. Einstein didn't stop with special relativity. His general theory of relativity revealed that gravity itself is actually the curvature of spacetime, and this creates another time effect that works in the opposite direction. Those same GPS satellites, orbiting 20,000 kilometers above Earth's surface, experience weaker gravity than we do down here. And in weaker gravitational fields, Einstein showed us, time actually runs faster. This gravitational time dilation causes satellite clocks to gain about 45 microseconds per day compared to Earth-based clocks. So now we have two competing effects, special relativity making satellite time run slow and general relativity making it run fast. The net result? Satellite clocks run approximately 38 microseconds fast each day. A tiny discrepancy that would render GPS completely useless within hours if left uncorrected. Here's where human brilliance meets Einstein's genius. The engineers who designed GPS didn't just acknowledge these relativistic effects, they embraced them. Before each satellite launches, its atomic clocks are deliberately adjusted to run slow, compensating for the relativistic effects they'll experience in orbit. Additionally, ground-based computers continuously monitor and correct for these time differences using Einstein's equations, making thousands of tiny adjustments every day. Think about what this means for a moment. Every time you navigate to a restaurant, find your way home, or track your morning jog, you're relying on a network of satellites that are constantly proving Einstein was right about the fundamental nature of reality. Your phone receives signals from at least 4 satellites simultaneously, and by comparing the tiny differences in arrival times, differences measured in billionths of a second, it calculates your exact position on Earth's surface. But perhaps the most mind-bending aspect of all this is what it tells us about the nature of time itself. We tend to think of time as universal, constant, the same everywhere in the universe. Einstein shattered this intuition completely. Time, he showed us, is relative, flexible, intimately connected to space and gravity. The GPS satellites orbiting above us right now are living proof that there is no universal now. That time itself depends on where you are and how fast you're moving. So the next time you casually ask your phone for directions to the nearest coffee shop, pause for a moment and appreciate the cosmic dance happening above your head. 24 satellites, each carrying the most precise clocks ever built, each existing in its own slightly different time stream, all working together to tell you exactly where you are in space and time. It's Einstein's universe, and we're just living in it, with incredibly accurate directions. Now that we've seen how Einstein's relativity governs the satellites above us, let's explore perhaps his most famous discovery, one that fundamentally changed our understanding of speed, energy, and the very fabric of reality itself. We're talking about the cosmic speed limit, the ultimate velocity that nothing in the universe can exceed, the speed of light. Picture yourself behind the wheel of the most powerful car ever imagined. Not just any supercar, but a vehicle that can accelerate continuously without limit. You press the accelerator and feel the rush as you blast past 100 kilometers per hour, then 1,000, then 10,000. In our everyday experience, we'd expect this to continue indefinitely. More fuel, more power, more speed. It seems logical, doesn't it? But Einstein discovered something absolutely mind-blowing. The universe has other plans entirely. As your imaginary vehicle approaches significant fractions of light speed, let's say 90% of light's velocity, something extraordinary begins to happen. You're now traveling at roughly 270 million meters per second, and the very laws of physics start to rebel against your attempt to go faster. It's not that your engine lacks power, it's that the universe itself is changing the rules of the game. Einstein showed us that as objects approach light speed, their mass effectively increases toward infinity. Think about what this means. The faster you go, the heavier you become, and the more energy you need to accelerate even slightly faster. It's like trying to climb an infinitely steep mountain. Each step requires exponentially more effort than the last. By the time you reach 99% of light speed, accelerating just 1% more would require more energy than exists in the entire observable universe. But here's where the story gets truly fascinating. Light itself, those photons streaming from your phone screen, from the sun, from distant stars, experiences something completely different. Photons have zero mass, which means they don't face the same restrictions that massive objects do. They don't gradually accelerate to light speed. They are born traveling at light speed and can never slow down. From the moment a photon comes into existence until it's absorbed by something else, it races through the universe at exactly 299,792,458 meters per second, not a fraction faster, not a fraction slower. This creates one of the most beautiful paradoxes in all of physics. From a photon's perspective, if we can even imagine such a thing, time doesn't exist at all. A photon that left the surface of the sun 8 minutes ago, from our earthly perspective, experiences no passage of time during its journey. To that photon, it leaves the sun and arrives at your eye in the same instant. It could travel for billions of years across the cosmos, and still, from its own reference frame, the journey would be instantaneous. Now, you might wonder, why should this cosmic speed limit matter to someone living an ordinary life on Earth? The answer lies in one of the most famous equations ever written, E equals mc squared. This deceptively simple formula tells us that mass and energy are interchangeable, and the conversion factor is the speed of light squared, an absolutely enormous number. Every time you turn on a light bulb, charge your laptop, or start your car, you're witnessing Einstein's mass energy equivalence in action. The nuclear reactions powering the sun convert tiny amounts of matter into tremendous amounts of energy, following Einstein's equation precisely. A mere gram of matter, about the mass of a paperclip, contains enough energy to power a typical home for thousands of years. This is why the sun can shine for billions of years, converting just a small fraction of its mass into the light and heat that sustain all life on Earth. But Einstein's speed limit affects us in more immediate ways too. Every time you use any electronic device, you're relying on the precise behavior of electrons moving through circuits. As engineers design faster and faster computer processors, they bump up against relativistic effects. The electrons in modern microchips move so quickly that engineers must account for Einstein's theories when designing the circuits, or the devices simply wouldn't work correctly. Perhaps most remarkably, this universal speed limit is what makes causality possible, the logical sequence of cause and effect that governs our reality. If information could travel faster than light, effects could precede their causes, creating paradoxes that would unravel the very foundation of logical existence. Einstein's speed limit isn't just a physical constraint, it's the guardian of rational reality itself. So the next time you see sunlight streaming through a window, remember, those photons have traveled 150 million kilometers in just over 8 minutes, carrying energy that was locked in matter deep within the sun's core. They represent the universe's ultimate speed limit in action, proof that even in a cosmos filled with unimaginable scales and forces, there are fundamental rules that govern everything from the smallest quantum particles to the largest galactic structures.